Hi, hello, welcome to the video. In this video, we'll be learning about chemical bonding and how it is related to food technology. But before we start, let's begin with an introduction. My name is Neethu, a student of food technology, with a NIM number of 26021A2940. So let's begin the video by asking a simple question. What is a chemical bond? Well, a chemical bond is basically an attraction between atoms caused by the outer or valence electrons. Because of said electrons, different behaviors may come out of it. The basic bonds that we have encountered are most definitely ionic bonds and covalent bonds. Let's start by explaining them and go to harder ones after we're done with this. So, this right here is a covalent bond. A covalent bond is a bond between two atoms that have electrons on the outer shell. They attract each other very much that the chemical bond is formed. The atoms share a pair of electrons. That is where the bond exists. The pair of electrons that bond the atoms are called the bonding electron pair, as you see here, and the pair of electrons that are not shared with another atom are called lone pairs, so right here. Symbol, yeah, you got that. Oh yeah, just a side note, the atoms generally occur in non-metallic atoms or with itself like H2O, water, or O2, oxygen. Now, on to ionic bonds. Ionic bonds are formed by attraction between positive and negative ions. What's an ion, you ask? An ion is basically an atom with an additional or fewer electrons. More electrons, it's a cation. Less electron, it's an anion. Not to be confused with onion. The bond is formed when one or more electron from the outer shell is transferred to the outer shell of the other. An example for that would be NaCl, table salt, and as you can see here, it pretty much explains it. And alright, now that I've explained the basic stuff, let's go with how it is related to food technology. So, there's a thing called a hydrogel, three-dimensional network of polymeric chains, and be cross-linked by chemical or physical bonds. Because it is cross-linked, it can have linear or branch structure and three-dimensional networks, which means that it can hold large amounts of water and can't be dissolved in water. And this, that we're just seeing right now, is basically the first thing that comes up when you look at the Wikipedia page. Now, hydrogels are generally used in agriculture. It increases the crop yields while using the same amount of water. Well, not only that, it can also be used in medicine as localized drug depots. But that's not why we're here. We're here because it can be used as part of food packaging. Well, potentially. Anyways, because it is good at absorbing water, it can remove moisture. So you just have to pack it together with food that's usually ruined when it has moisture, and boom, problem solved. And it also has a potential to reduce the risk of microbial contamination while preserving the sensorial, appearance, odor, flavor, taste, and texture characteristics of packaged food, because some hydrogel has antioxidant and antimicrobial properties. So yeah, very much useful for food packaging and preservation. And yeah, that's basically it. Thanks for watching the video, and these are the references.